Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about squares and its properties. Alright.
So let's define what is a square. A square is a polygon with 4 sides where all sides have equal length and every interior angle is a right angle. So this is an example of a square. And let's identify the different properties of a square. So according to the definition, one of the properties of a square is all sides are congruent or all sides are equal and all 4 angles are right angles. Okay, as you can see, it is based on our definition. Another property of a square is that opposite sides are parallel. We can say that side AD is parallel to side BC and side AB is parallel to side DC. So take note that since opposite sides are parallel, we can also say that a square is a parallelogram. Alright, okay, next, let's talk about the angles of our square. So consecutive angles of a square are supplementary. So we can say that angle A plus angle B is equal to 180 degrees. Just like saying 90 plus 90, that will be equal to 180. Alright, next, let's talk about the diagonals of a square. So just like a rectangle, the diagonals of a square are congruent. So we can say that the diagonal AC is congruent to the diagonal BD. Alright. Okay, the diagonals of a square bisect each other. So, just like a parallelogram, the diagonal of a square bisect each other. So, we can say that segment AE is congruent to segment CE and segment BE is congruent to segment DE. Alright, just like a rhombus, okay, each diagonal of a square bisect 2 angles of the square. So, according to our figure, so the diagonal will cut each angle into 2 congruent parts. Okay, so we can say that angle ADB is congruent to angle CDB. And last one, the diagonals of a square are congruent and they are perpendicular. Okay, so it will form a 90-degree angle and they are also congruent. So in conclusion, we can say that a square is both a rectangle and a rhombus. A square is an equiangular rhombus and a square is a equilateral rectangle. Alright. Okay, let's have some examples in solving parts of a square. So for example, we're given this square and we're going to solve for the value of x and y. Let's start first in solving for the value of x. So in solving for the value of x, we're going to use the property all sides are congruent. So we can say that side QW is congruent to side RE. So let's substitute the values of each side. So we have 9x plus 28 is equal to 58. And let's solve for the value of x by transposing 28 to the other side of the equation, applying the subtraction property of equality. So we will have 9x is equal to 58 minus 28. So we will have 9x is equal to 30. Let's divide both sides by 9. X will be equal to 10 over 3. Alright, now let's solve for the value of y. So in solving for the value of y, we will still use the property all sides are congruent. So we're going to equate, so we can say that side WE is congruent to side RE because all sides are congruent. Let's substitute the values of each side. So we have 4y minus 14 is equal to 58. And then let's solve for the value of y by transferring negative 14 to the other side of the equation using the addition property of equality. So we will have 4y is equal to 58 plus 14, and let's combine like terms. 4y will be equal to 72. Then let's divide both sides by 4. Y will be equal to 18. Alright, okay, let's have another example. So for example, we're given this square and we're going to solve for the value of x and y. Now, let's solve for the value of x first. So we can say that the diagonals of a square are congruent and perpendicular. So we can say that the measurement of angle WTE is equal to 90 degrees because they will form perpendicular lines. Okay, by substituting the value of the measurement of WTE in this equation, we will have x is equal to 90 degrees. Alright. Now, let's solve for the value of y. In solving for the value of y, we will use the property or one of the properties of a diagonal of a square. So each diagonal of a square bisect two angles of the square. So we can say that if the measurement of QWE is equal to 90 degrees, since all angles is equal to 90 degrees, we can say that the measurement of TWQ will be equal to half of 90 degrees, and that will be y is equal to 45 degrees. Alright, okay, let's have our last example for today. So for example, we're given this square and we're going to solve for the value of x and y, and one of the given is segment RW, our diagonal, is equal to y. Okay, so let's solve for the value of x first. In solving for the value of x, we will use the property about the diagonals of a square. So the diagonals of a square bisect each other, so we can say that segment QT is congruent to segment ET. So let's substitute the value of QT and ET, and we will have 3x minus 10 is equal to 17. Then let's transfer negative 10 to the other side by applying the addition property of equality. So we will have 3x is equal to 17 plus 10. So 17 plus 10 is equal to 27. Let's divide both sides by 3 and x will be equal to 9. Let's solve for the value of y. So in solving for the value of y, we will use the following properties. First is the diagonals of a square are congruent. Second, the diagonals of a square bisect each other. Using this property, we can say that segment QE is congruent to segment RW. The diagonals of our square will be congruent. And also, segment QT is congruent to segment ET. We will use that in identifying the measurement of segment QE. So, we know that ET is equal to 17, and we also know that QT is equal to 17 because they are congruent. By applying the segment addition postulate, we can say that QE will be equal to QT plus QE. So let's add the measurement of QT and QE. 17 plus 17, that will be equal to 34, and that will be the measurement of QE. Now take note that we have equal diagonals. Therefore, we can also say that QE, segment QE, is congruent to segment RW. And let's substitute the value of QE and RW. We will have 34 is equal to y, and the value of y will be equal to 34. Alright.
Now that you already know about the properties of a square and how to solve problems involving squares, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.